Okay, this is MITD 1534. Today we're going to look at the natural logarithmic function, which we also call the ln function. And this is just a log as it says there. It's the natural logarithmic function. So it's just a log function. Now the difference between log and ln is just that for the log, our base is, if it's just a normal log, as we said the other day, then the base there is 10. Right, if we don't indicate any base, then the base is 10. When we talk about the ln, then it's just an absolutely normal log, but then the base is e. Now remember, e is 2,7, close to 3, as we said here, 2,718, which is close to 3. That's why I'm thinking about the 3. So it means that it's greater than 1. So when we look at the graphs, then it will just be a graph, a normal log graph where the base is greater than 1. So the ln function will look like this here that you have in your books there, which is just absolutely the same as like the normal, log with the base 2 or log with the base 3 will be looking like. So it will still go through 1 here, and it will still approach the negative y-axis and bend like that. Remember, it is then symmetrical with the e function in the y is equal to x, where the e function will then go up like that, also through 1 here. Okay, so it's the inverse of the exponential e function, the ln, we call it the ln. So when we see ln, just understand that it is a log, and therefore it will obey all the rules for logs. So we have looked at the properties for logarithms. So the properties here for the ln is exactly the same. The ln of 1 will be 0. Remember that the ln of e will be 1 because the base is now e there. Let me just do that a bit better. The base there is now e. And then e to the 1 will be e. The circle, e to the 1 will be e like we looked at. And then this is e. So remember, if the base and the e there is the same with the power, then the answer will be the exponent, because we said log means exponent. So ln still means exponent. And then remember, e to the ln, because you are doing the inverse of each other, will just give you the x back. So this is important. E to the ln will give the x back, and ln to the e will give the exponent back. Okay, because these are each other's inverses basically. If you take ln of e, you will just get the exponent back. And if you take e to the ln, you'll just get the number back, the x, you'll get the x back. And then the 3 laws, like we've done, is exactly the same as for log. A single ln x plus ln y. So the plus here, multiply here, like we have discussed in the previous sections. And the minus here, subtracting there, will be a division here. And the power that can go to the front there. Okay, so we need to understand that everything in logs is applicable here. So if we have to make a single log, then we will also be able to make a single ln. So if we look, for instance, at what we have over here, ln minus 2 ln, and we want to write that as a single ln, then the minus again is going to be division. The power 2 there we can take back like we've done here, take back the 2, and then we have ln minus ln. So in the end, those 2 with the minuses in front will go to the denominator. Like you see here, I've taken out a common factor of -1 here to show you that that forms a plus. So this will be now in the numerator, and this whole thing will be in the denominator. So, okay. So, remember that if we have here the ln plus the ln, that will form a multiplication. If I only look at the brackets here, with a plus there, that will form a multiply, like we've done here. So that will form the multiply, and the minus will tell me that this part will go to the denominator. So there I have my single log. This is now ln, but it's still a log. So there I have my single ln. And then I can just simplify if something can be simplified. Okay, if I have to expand, and you are going to get questions in the test on this, then I will know that that division will becomes a minus. So ln e minus, then ln of the bottom here. But there's a multiply, so that will become plus. So ln x2 plus ln squared root y. Now I'll do my powers. Okay, I did here first, I took in the minus through the brackets there, so it's 1. Ln of e is 1. We said so. Ln of e is 1. It's one of the properties. So minus, and then the 2 can come to the front. The 2, the rule, the property that says that that power can come to the front. So it's 1 minus 2 ln x. The half can come to the front, minus a half ln y. And then I have it in expanded form. Okay, so we will ask you to expand and to write as a single ln. It's the same as for logs. So if you know you exercised your logs and you've exercised to expand and to write as a single log, this is nothing. Okay, so let us just look at a couple of sums here that we can do. So remember now that ln of e will just be 1. Alright? The ln of e to the negative 6 will just be negative 6. Because the ln and the e sort of cancels one another. So the ln of e to the 2 will just be 2. The ln of e to the 5 minus 3x will just be 5 minus 3x. Okay, the ln and e cancels. The ln of 1 is 0. It's a property. We must know that. Here we have e to the ln. Now e to the ln will cancel one another because it's its other inverses. So therefore, this will just be 2x plus 3. Okay, just going to get the number back. E to the ln will cancel, just get x back. E to the ln 4 will just be 4. Okay, so it's not difficult, but we need to understand the properties. We need to understand the properties. And here is now again to write as a single ln, for instance. So let us take this number c. Alright, so we can take the powers in first if we want to. So then this is going to give me ln x to the 4. The power goes back. Minus ln y to the 3. The power goes back. The power goes back. Minus ln z. Okay, I can take out a common factor again here, and that will give me a plus. But if I realize that now, I can just write it now as a single ln. Ln, the x4 will be above in the numerator, and those two with the minuses will come down here, y3 times z. Okay, so pretty easy actually. Alright, so let us do number b here to expand. Okay, so remember there's not just one way, but I like to do my minus the division there first. So I'm going to say, listen, I've got here ln a4 b to the, I can already now write b to the half if I like to, because of the square root is a power half. And then the division becomes minus So minus ln c. That's c there. Okay, minus ln c. Okay, minus ln c. All right, now there's a multiply. So I'm going to use the multiply to expand. So this is then ln a4 plus ln b to the half. And then of course minus the ln c. And now I can just take the powers to the front. So it's 4 ln a plus half ln b minus my ln c. And there I've got it in expanded form. Okay, so once again, you will have to be able to write a single ln as a single ln, and you will have to expand a single ln into its components. All right, so you can look at that. Then the other important part is how to solve. Okay, so let us look, because the example will show us exactly how to do. I've done the steps here for you at the top there. So try to isolate the logs on one side of the equation, and then you use your little circle movement. Or you can also do a single log on the left hand side and a single log on the right hand side. It's your choice. So that is why we must be able to write as single logs. Okay, look at the steps there, but let me explain it here in the example, because it's just going to make more sense. So what you can do, one method is, as I've written, I also did the steps here on the right side, is isolate the logs now as we said on one side. Meaning, move over your logs, let's say to the left hand side. I've used the left hand side here. So bring over all the logs to the left hand side and keep your numbers on the right hand side. So all the logs on the left hand side, and then keep your number on the right hand side. And now you go over and make it a single log, because we've done that now, how to make a single log. It's easy for us now because there's a plus, so it must become a multiplier. So now I sit with this. Okay, so how do we do that? We set that circle must always be true. So 4 to the 1 must give me the bracket. So 4 to the 1 must be equal to the bracket. And then bring over, because this is quadratic now. We've done quadratic equations. So bring over, solve, and then we have two answers. And now please be very careful now that the log of a negative number does not exist. That is not applicable. It's no solution. It doesn't exist. So this x equal to negative 1 is going to make this log negative there. It's also going to make the log negative there. So that x equal to negative 1 is out. So the only answer here will be the 4. Okay, so please do not forget to check your answers. Don't just accept the logs as it comes out. You cannot have the log of a negative number. It is explained and discussed here also in the top there, so it should not be a problem. Okay, so pretty easy actually, but remember we will tend to ask you more ln. Okay, so let us go to B here, which is the ln. All right, so we need to solve this ln x plus 2 plus ln. Okay, so here once again move your lens. Remember, ln is just a log once again. So move it over, and then the plus becomes multiply. Remember, we're going to make a single log, né? So the plus becomes multiply, and the minus becomes division. And remember that your base is now, okay, let me just get another, that's not going to work, so let's just get a little pen here. So the base here is e. So remember the circle again. E to the 0 must give me that. This is what we did here. E to the 0 must give me that. So e to the 0 is 1, and I know how to solve that. So I'm going to do cross multiplication and just solve that now. Okay, that's what we did here. Again, we get a trinomial, solve it, and we see the answer is 5 and 3. Now be careful, don't just accept that answers, do the check. Remember, you don't have to show the check, okay? You don't have to show the check. I did it here because this is to help you to see what I did. So I looked and I checked if both answers correct, and in this case, both of them worked. Okay, so here we have then another question that we will ask you. So remember now, we have expand, we have to write a single, and then we have this equations, and now we go over to how do we solve now exponential equations. Okay, this is what makes this powerful, the logs powerful. Remember now, if we have 2 to the x is, say, 8. That's the only ones we could do in school, and so on. Okay, you did a bit of logs there, but my point is, normally throughout grade 8, grade 9, grade 10, and so on, we said that you must have the same base on this side, and you must have the same base on that side. So then you could say, therefore, x is 3. Okay, so that we are used to do. But what now if I have 2 to the x is 5? How do I solve that now? And this is where ln or log comes in. Okay, so you can decide if you want to use log or if you want to use ln. Okay, so if you have 2 to the x is 5, you can then say, okay, if a number is equal to a number, the ln of that number, 2 to the x, must be equal to the ln of that number, ln 5. Right, now we do the properties. This x can go to the front. So x ln 2 can be ln 5. And then we just divide by the ln 2. So x will be ln 5 over ln 2. And I can go to my calculator and I can solve that. We can, I think I've got my calculator here. Let's someone do that quickly. So we take ln, you see it on the calculator, ln 5 over, remember it's now the ln over the ln. Just be careful that you don't do ln 5 over 2. It's ln 5 over ln 2. So it's ln 5 at the top. I do the fraction mode. Ln 2 at the bottom. I'm getting 2,32. This is 2,32. I like that because 2 to the 2 is 4 and 2 to the 3 is 8. So it should be closer to 2. So 2,3 looks good. Okay, so this is how we can use ln and log. Remember, you could also have done it through logs. You could have said log 2 must be log 5. But I think you must rather exercise your ln now, because remember, we're moving into the university, up in the university lines now, and we want to get used to ln and e. So if you can use ln and e, because you need to get used to the concept of that. So the same here now. If we have this number a here now, okay, we can put a ln and a ln. That x plus 3 comes to the front, and that x comes to the front. Okay, now we've got x this side and x this side. Now we've learned from school all over, when we have x, we need to get all the x on one side and then the numbers on the other side. That didn't change. So we're going to multiply out this bracket here. So we're going to have x ln 2 plus 3 ln 2. Right, let's go there. So we're going to multiply out, and then we have x ln 2 plus 3 ln 2 is x ln 7. So what are we going to do? Get all the x to one side, get all the numbers to the other side like we always did. Then we can take out the x here as a common factor, and we can divide by the bracket. So our answer is going to be minus 3 ln 2 over the brackets here. And that we can easily work out with our calculator. And the answer is going to be 1.660. You can just check that. Alright, so that is then also very, very important. And then the other thing that is important, if we have e to something. So make a note. If we have e to the power, we put ln in front, because we said in the properties ln will cancel e. So it's very easy. So when we need to solve this number b, okay, we will just put a ln here and a ln there. The ln and the e will cancel one another. So we will just have minus 3 to the x. You don't even have to show this step. You don't have to show it, okay? You can just say ln and e will cancel, and I've got my minus 3,6x. And then I have ln of 9.74. Remember, ln on this side, ln on that side. Okay, so ln and e will cancel here. And very easy, I can just divide by minus 3.6 now and find my answer. Minus or negative 0.632. Very, very easy. Okay, so this is the two types that you must know now. Also, when you do these exercises, and you're welcome, we're going to discuss it again, but you're welcome to contact me if you have problems, but concentrate more on the e and the ln. Okay, try to do more on ln and on e here. I think it is just better for you. Okay, so look at the examples we've done, and yeah, I think then your people will be fine. Let us do together here number 10. Okay, where we have the ln now. Okay, so ln x plus 5 minus ln x minus ln 4x must give me 0. Okay, so make a single ln. So this is going to be ln. X plus 5 is going to be in the top numerator. And both those two is going to be in the bottom. So this is going to be x times 4x. This is going to be 4x squared. Okay, and that is 0. And remember, the base here is e. You don't have to write it, but it's just that you understand. So remember now, e to the 0 is going to give me this. Okay, so that means I'm going to have x plus 5 over 4x squared is 1. Because e to the 0 is 1. Do my cross multiplication. 4x squared must be x plus 5. Okay, bring over. So 4x squared minus x minus 5 must be 0. Let's see if this is factors. But otherwise, go to the formula. Okay, and do your formula. And then remember, the last thing is to come back and check if they're both valid. Both your answers are valid. We've got 1 and 4 here. We've got 1 and 5 here. So 5 minus 4. Remember that AC method. 4 times 4 is 20. And 20 will be 4 and 5 will give me a difference of 1. So I knew it's going to work because I still apply that. that AC method that we've done to see quickly if there will be factors. Okay, so we can put in the factors here. It's not difficult at all. So it's going to be 4x and x. And it's going to be 5 and 1. And I must have minus 5 and plus 4. So that I can have minus 1. So x is going to be 5 over 4. Or x can be negative 1. Okay, now I go back and I check. This 5 over 4. No, it's not going to make it negative. No, it's not going to make it negative. No, it's going to not make it negative. You're fine. Okay. And then I go to minus 1. Minus 1. No. Oops. Oops. Okay, this girlie is out. And the boykie is in. So x is 5 over 4. Only answer applicable. Okay. I like these sums. And you can get a lot of marks here. Alright, okay. Because we just need to understand everything we've done, then it's really not difficult. Let's also do an E1. Okay, so let's go here. Okay, let us do, I think we should do 2 here quickly. And then I think we will be fine. So, let us do number 3. Okay, so we have here 32 e to the 0,04m, and we have 128 here. So the very first thing that we must never forget, we want the power to be alone. Isolate the power. That didn't change. That's not new for us. So we're going to divide by the 32. So we're going to have e to the 0,04m, and then we're going to divide the 128 by 32. Let's see what we get. 128 over 32. That gives me 4. Oh, that's nice. It's giving me 4. I should have seen that. My lazy brain, because we can really see that that should be 4. Okay, now we've got e. What do? We put ln on both sides. I knew you said it to yourself because you are awake and you've listened. And a ln and a e will cancel one another. So this will just be 0,04m. Okay, that is ln 4. That I'll keep for the moment. I want m. So divide by the 0,04. So this will be ln 4 over 0,04, and that go to the calculator. All right, ln 4 at the top, 0,04 at the bottom. It looks like 34, I hope I did that correctly. Just check it, please. 34,66. Okay, 6. I really think this is not difficult. Okay, let us also do something, this is the same, 6 and 9. Eeny, meeny, miny, mo, I must take you. Okay, so we take this one. 2 to the x minus 1 is 7 to the x. I must solve for x. How do I do it? Well, either put a log in front of both or ln, but I'm going to exercise the ln. So we put ln in front of both. So ln and ln. Right, and then this is 2 to the x minus 1. And this is 7 to the x. Okay, now apply the properties. This x minus 1 comes to the front. And this x comes to the front. Now I need to get x on the same side. So I need to multiply out the brackets there. Okay, I'm just going to make a little arrow here. So therefore we get x ln 3, x ln 3, and we have minus ln 3, minus ln 3, and then we have on the other side x ln 7, x ln 7. Right, get my x together. So x ln 3 minus x ln, x ln 7 is then ln 3.
So are you sure
Alright,
that's a
so
3?
isolate by taking out the common factor, so that I could just have one term here. So it's ln 3 minus ln 7, and that is ln 3. Divide by the brackets. So x is going to be ln 3 over ln 3 minus ln 7. Okay, hope you're still with me here. And okay, so that we can work out on the calculator. So go to the fraction mode. I hope I did it correctly. I'll hear now from you, but let us just see there. So it's ln 3 at the top, come down, and ln 3 minus ln 7. Okay, just get it here. Ln 3 minus ln 7. And that gives me, it looks like negative 1, 3. Negative 1, 3. Negative 1, 3. Let me just put that negative a little bit better there. Sorry, just get the correct stuff here. Okay, so that is negative 1, 3. Okay, so this will conclude then our unit 13. And Friday we are going to look at unit 14.